Welcome everyone. I'm Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions.
We are very excited to host today's event, Master AI and ML on Google Cloud. Our presenting today's topic is Imran Ahmad. Imran Ahmad is a data scientist, author, and cloud instructor with extensive experience in designing, implementing, and optimizing intelligent algorithms. He has a passion for simplifying complex technologies, making them accessible to learners and professionals alike. As an AWS authorized instructor and Google Cloud authorized trainer, Imran specializes in delivering impactful training sessions that enable professionals to master cloud computing and data science concepts. His passion lies in teaching and creating innovative solutions that solve real-world problems and drive measurable value.
Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges.
We have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the AI and data practice areas.
Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com.
In this session, you'll gain expert insights into mastering AI and ML on Google Cloud. Our focus today is on leveraging advanced tools and frameworks to build efficient machine learning models, scale your AI infrastructure, and apply cloud-based solutions effectively. By the end of this session, you'll have actionable strategies to elevate your cloud journey.
And now I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handouts section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic.
Hi, Imran. Thank you so much for joining us today.
Okay, good morning, good evening, and good afternoon, wherever you are. So welcome to this webinar on an exciting topic that is mastering AI and ML on Google Cloud. So the focus, the way we have designed this webinar for you is that we'll talk about AI and ML, but the focus of this course would be that how we are going to do that on the Google Cloud. what Google Cloud has to offer to solve these problems that relates to AI and ML. And usually we move to the cloud for providing the solution to the large scale problems where the volume, velocity, variety of the data that has become huge. So we'll try to look into the actual problems that we can solve using Google Cloud. And we'll also look into the life cycle of a machine learning project. And within Google Cloud, you should be able to manage the complete life cycle from start to the end. So this is something that we'll be doing. Let me introduce myself. My name is Imran Ahmed, and um, my full-time job is with Canadian federal government. That's my full-time job. And yeah, what I do for living is that, let me go to my LinkedIn page. That's the fastest way that I've learned to introduce myself. That I have written this book, 50 Algorithms Every Primer Should Know. And this is very much related to the topics that we will discuss today. And this book is the bestseller for the second year in a row. And this very much relates to the how we can squeeze out the maximum out of Google Cloud through the algorithms, and we will discuss that in this course. As I mentioned that what I do for a living is that I am a data scientist working for Canadian federal government for the last 10 years on the same project. These are people who come for immigration, for student visa, for business visa, 9 different lines of business, and how we use the power of AI. And we do use Google Cloud. And this is where my practical experience, what works and what does not work. We use AWS and Google Cloud. We'll try to see that which how we can strategize for these large scale problems. And I'm also a professor at Carleton University. I did PhD from the same university, and I did master's from Carleton. I'm an authorized instructor for both AWS and Google Cloud, and that's about me. So let's go back and let's now look into um, Google Cloud and see that why, in my point of view, Google Cloud provides a complete solution for managing the complete life cycle of a large scale machine learning project and what it has to offer. So we'll talk about this as well. So let's look into the first part of the slide, and let's try to understand that what exactly is AI. When we talk about AI, what we mean by AI, and what is the difference between AI and ML, and how we can use that on Google Cloud. At this point, I want you to pause, take a step back, and think about that when you see this word AI, what comes to your mind? So organize your thoughts. We will discuss that. We will revisit in a minute. But let me first introduce you to what Google Cloud itself is. Now, when we talk about Google Cloud, so you can think of Google Cloud as having two dimensions. There is a data dimension, how you're going to store the data. What is your strategy? What sort of data it is? Is it structured data, unstructured data? Uh, do you need SQL database? Do you need NoSQL database? Everything to deal with data. AI is all data centric. Before we do anything serious, we need to figure this out, that what is the architecture of our data dimension? And the second thing is compute. Okay, now data is there. How you're going to process it, how you are going to compute it, and what is available in Google Cloud for it. Let's look into that first. For those of you who have never seen the landing page of Google Cloud, so the Google Cloud, the landing page looks like this. It's the console. This is the web page. This is the easiest way you can use Google Cloud. And now all the services that are offered by Google are provided through this page. And if you want to go to a particular service that you have in mind, there are two ways to do that. Imagine yourself, you are in a library and you're looking for a book. And if you know the name of the book, you go straight away to that shelf and grab that book for yourself. But if you are not sure about the name of the book, then you go to the shelf, for example, tourism or cooking or something else that you are after. And then you try to find the book relevant to that topic. So this page, this landing page is like that library. If you know the name of the service that we need, it is right here. It will, you just write the search and go straight away to that service. And if you do not know, you have a broad idea. Okay, I'm looking for something to deal with data warehouse, something about computing. I'm looking for VM, but I don't exactly know the name of the service. In that case, on top left-hand side, you will see that this is the bookshelf, we call it. It is right there. Navigation menu, you click here. It will show up here. And from there, if you want to see all the products, now it will show you that, okay, for example, in management, we have these products. In compute, we have this. For storage, we have this, and it goes on, right? And now, when we talked about the data in compute dimension, so this is where, so you will see that this is exactly what I was talking about. These are the services that are provided in the data dimension right here. These are the different ways. I'll talk about that, the important ones, how you're going to store it. And in the compute dimension, if you go back here, it shows you that what are the different services that are there in the compute dimension. Data dimension and compute dimension, right? So data dimension and compute dimension, there's a design pattern that we use that is called ephemeral, temporary compute dimension and long-term data dimension. We'll talk about that later. But for now, so this is these are the services, what we are related to the compute dimension. And these are the ones that are related to data dimension. Let me highlight some of them and talk about this, move on, and then I'll come back. Perhaps the most important one and the one that is used quite often, that is right here, the cloud storage. It's like your Dropbox. It's like your Dropbox. It's like your in S3, for example, in AWS. It's the object storage where you store a file or a book as an object. So this is something that we use. This is the object storage that you have. Right? And in the compute dimension, the one that I want to highlight is this one. Two of them, in fact, A and B. A is the compute engine. It's like your virtual machine. Instead of using the laptop, what you do is that you are using the compute engine to get things done. And Kubernetes is your Docker container, container orchestration, as we call it. So this basically provides you a bit of a power, and file store is basically your file storage, like EFS in AWS, or if when you're working together as a team in your organization, sometimes we have the shared folders, shared network drives. So file system is something like this. So this is the data and compute dimension. And with this, if we go back here, you will also find that there are to keep going down. There is networking. This is about the distributed computing. This is about the serverless. Then comes the database. It's a house full. but I will bring it here to complete it. But I will only talk about the ones that are really important, right? So with this, we have enough in our data and compute dimension, right? So we'll see that how actually we use it. So this gives you the overview, but let me highlight some of these. You have, if you are looking for structured data, then you will look at this SQL, Cloud SQL. If you're looking for unstructured data, then what you will be doing is that you will be looking at big table, right? Now, Spanner is, you can think of that as large scale managed service for structured data. And so this is your data and compute dimension in Google Cloud. So let's go back and let's try to figure out that what is a typical life cycle of a machine learning project and how Google Cloud addresses that. So for that, let's try to figure out that how we are going to. So let's talk about this. Life cycle of a typical machine learning project. So life cycle of a typical machine learning project, it is the best way of looking at that is you may be using different life cycle tools, but the most popular one that is cross industry standard is crisp DM lifecycle. And then we'll talk about that how Google Cloud implements that crisp DM lifecycle. So I will have that lifecycle on my left hand side and what Google Cloud has to offer on our right hand side. And we will try to see that how this is almost one mapping between the template and the implementation. So let's go for the template first and see that what is crisp DM lifecycle. Write on your chat if you have heard about it. But if you haven't, don't worry about it. So we will look into that. Okay, so the crisp DM life cycle, if I go here, so if you Google, this is cross industry standard process for data mining. Let's grab a diagram from here. Now, this is a crisp PM life cycle, and let me talk about how Google basically implements this crisp PM life cycle. So for that, let's spend 5 minutes understanding this life cycle, and then we will go to the Google Cloud, and we'll see that how Google Cloud is its tool, Vertex AI, is just an implementation of this template. So any machine learning life cycle, it comprises of these phases. First of all, we always try with what needs to be done. These are the stakeholders. It's the what part. This is the question that need to be answered in machine learning. It's a layman, non-technical terms. For example, you are using this machine learning to for fraud detection. You are using this machine learning to differentiate between a malignant tumor and a benign tumor. You're using this machine learning to uh, approve or reject a mortgage application. You know, whatever is there with all the details, you start with business understanding. This is the non-technical portion. Now, in order to get this done, we need data. You cannot do anything without data. So it means that data needs to be here. Data needs to be in the middle. Data is right here. And this data is our expectation is that this data has everything we need to answer this business question. That is our assumption. It may or may not be correct. We may or may not be the data with the right quality and with the right patterns to answer this question. So for that, what you need to do is that you need to first look into the data. And that's why you will see that this is the data understanding. You try to understand data and try to understand that whether we have enough data, whether the quality is right or not, and what are the summary characteristics coming out of it. So we use three techniques to do that. Technique number one, visualization. So we need to create all sort of visualizations to see that whether we have enough data and what are the summary statistics. Second one, we generate reports, detailed reports, and we'll see that which tools can we use. And the third thing is that we also use some algorithms. They are called semi-supervised ML. So I will talk about semi-supervised ML, but the thing is that we understand data. We know that whether we are able to answer this question or not. Otherwise, if you zoom into there, so we will see that this is to and fro. We need to go back to business to tell them that we do not have data for this what you asked, right? So once you have understood the data, in data understanding, we do not change data. We just try to understand that. Now, once we have done that, the next part that we have is about preparing data. This is heavy lifting. We need to process the data. We need scalability. We need pipelines, ML pipelines. We want to transform the data so that it's ready for algorithmic use. And these two portions of it, we call them as data engineering. These two are the DE portion. If your friend is working as a data engineer in a machine learning team, so that person will work there in understanding the data and preparing the data. Once the data is prepared, the time has come to use it for ML, and here we will be using it. It has three components. A is modeling, B is evaluation, and C is deployment. Modeling means that we try to formulate the causal relationship between label and features. This combination of feature generates a fraudulent transaction. This combination of feature generates a genuine transaction. This combination of feature is will cause rain tomorrow, and this combination of features, if temperature is this, humidity is this, it will be a dry day. So in modeling, we formulate the causal relationship between the labels and feature. But before we can use it for production, we need to evaluate and we need to put it to deployment. So we go towards evaluation and deployment, right? Now, in evaluation, we need to quantify that how powerful, how accurate that formulation is, and whether our basic assumptions, they were in the right direction or not. And once, if in many cases, what you will have to do is that you have to, you are not done in the first go. So you will have to repeat this cycle as many times as necessary. You will have to basically for days or weeks or even months till the time comes and now you are ready to deploy. Now, the thing is that if once you have evaluated, now you will deploy. When you deploy it, it will create an endpoint. This thing. Now it will, once the model is trained, once it's evaluated, and when it's fully tested, now what we can do is that this whole thing it all becomes a black box for us. And this model is deployed and anyone can use this model. So this endpoint that are created, this is called a creation of an endpoint. I want you to keep an eye on all the terminology that we have used because in next couple of minutes, we will be switching to GCP, Google Cloud to see that how this CRISP-DM lifecycle is realized in Google Cloud. So let's define the terms that we have used in this CRISP-DM lifecycle. So the first term that I used is basically is machine learning itself. And in the beginning, I said that think about machine learning and think about AI, and let's try to define them. That everyone has some sort of definition in mind when we talk about these terms. So I just wanted to basically talk about this, that what are these terms and what is the tool of uh, to implement this cycle in Google Cloud. Now uh, AI, artificial intelligence, if you want to talk about AI, now AI is something that is conceptual. It defines the wisdom in machines, that how you can how machines can be used for problem solving, right? It's the simulation of human intelligence by machines to perform tasks like learning, reasoning, problem solving, decision making. So that is AI, artificial intelligence. So I said that I want you to think about in your head. Let's try these two things. So, so AI, it's a simulation of human intelligence by machines. And we are looking for tasks like learning, reasoning, that is very difficult. Machines is a blind spot for most of the AI solutions. Problem solving and decision making. We are asking them to do a lot. It's not easy to do, right? And if you talk about machine learning, now machine learning uh, is so this is basically our expectation. And machine learning is a subset of AI that enables machine to learn patterns from data and improve performance of tasks. And we do not make any explicit assumptions about it. So that is called machine ML. So ML is a subset. So let's talk about this. So the diagram that you must have seen. So ChatGPT is an example of ChatGPT, an example of machine learning. Generative AI is an example. So the example of ML is, so if you look into examples, Gen AI, or you can see that classifiers. These are all examples of ML. And the definition that we would like to do for ML is that is a subset. If you look into ML, ML is a subset of AI that enables machine to learn patterns, right? So the diagram that you must have seen before in one form or the other, it is like this. The larger thing is AI. Now, larger thing is the simulation of human intelligence, wisdom. Very difficult to do that. Uh, Teaching, expecting machines to learn, reason, solve problems, and enable decision making. ML is one way, the best known way of implementing it. Maybe in future there will be other things that may be coming to implement AI, but our best shot at this is using algorithms, and it's a subset of AI. This is the point I want to make here. It's a subset of AI. Okay, now let's go to Google Cloud, and we have looked into these basic concepts. Let's see that how Google Cloud helps us implementing this crisp DM life cycle. So for that, what I'll do is that I will take a picture of this one and bring it here. And I will introduce you a tool that is called Vertex AI. Vertex AI, if you go back here, and here if you go to Google Cloud, I said that Google Cloud is, you can go to Google Cloud right here. And if you know the name of the tool, you can just write it here. Vertex AI is the name of the tool. You write it there, and Vertex AI is the tool that is used to implement to manage this crisp DM life cycle. On left hand side, the landing page looks like this. There will be tutorials here. And there's a Vertex AI Studio. There's a model garden with this refreshing name. And you will see there is model development. You can prepare the data. I said that that is heavy lifting, preparing the data, deploy and use. So you now all of a sudden, many of these things may make sense to you. I'll talk about this, that how it relates to KISS-PM life cycle. But first, let's make it just a bit bigger. Let me know in the chat if this is large enough you can see. Okay, it seems that it's good. So now let's look into what you can do. This is the landing page as you go to the specialist one window operation that we have for Vertex AI. You know, now let's look into what Vertex AI is. Let's define it first, and then we'll see that what are the components of it. And as I mentioned, that it is a realization of this crisp DM life cycle. So let's first define that what exactly is Vertex AI. So Vertex AI. It is Google Cloud's single window operation for building, deploying, and managing machine learning models at scale. It implements the complete machine learning life cycle. It has a bunch of tools that make it possible to realize the machine learning model end to end. And the tools it has, so out of the tools that are there, the 5 tools that are critical, that are core of this Vertex AI, let me write it down here and then I'll talk about it. So those 5 tools, let me show you one by one that how they look like. First, we have the Vertex AI Workbench. Let's look into this. What is Workbench? Now, the term Workbench is used in general and by Google to indicate an IDE, integrated development environment, that is called a workbench. And this is for IDE where you are developing. This belongs to the dev environment. We are developing code. You are creating a machine, and you want that machine to solve a problem, but you are in the process of developing. You need an IDE. You need Jupyter Notebook. So let's look into this, that how we can do that. So for that, what we'll be doing is that if we go back here, on left hand side, you will see that you keep going down. You'll be looking for model development. First of all, you'll see here, Workbench is right here, notebooks. It's right here. And what it shows you is this is the Workbench. In this Workbench, you will create a notebook and it will automatically create the backend for you. You need to choose it, but it will create for you. Let's see. So this is the IDE. This is your playground. This is your creative space as a developer, where you want to create a solution, provide a solution. This is where the full power of Google Cloud is at your disposal if you want. And the language of choice is Python. So the full power of Google Cloud is available to you as a user, and you have the Python environment by default and with Jupyter Notebook. Let's see how it works. And the backend is automatically provisioned for you. If anyone has worked in AWS, SageMaker is in AWS, but SageMaker has a concept of domain. It is a bit more complex to manage. This is very simple. I like it, the way Google has implemented it. You just go there and on left hand side, you will see that there is a workbench. Just need to click there. And what you do is that there are three different types of notebooks: instances, user managed, or managed notebooks. And let's look into them one by one, what they are and how we can use them. If you go back here, these notebooks that we have, they are one of the three types. Again, this is your, as a developer, this is the gateway to creativity. This is the grand entrance, if you can visualize that. So if you want to look into this, there are three types of it: instances, user managed notebooks, and managed notebooks. What's the difference? Instances are the ones where it will create a pure virtual machine, an instance as we call in Google language, without anything installed on top of it. You have to install it. It will not install TensorFlow. It will not install any framework on it. It's the pure VM for you. That's it. User managed, it comes with the framework installed. You want to, this one is a fresh laptop from Amazon delivered to you. And this one is, if you go to an NVIDIA conference, sometimes they give you laptop with the tools installed. So this is that laptop. The tools are installed. Now, third one is managed notebooks, where you want elasticity infrastructure. You want the collective power of the cloud to create very powerful solutions. This is where you will use managed notebooks. They are Docker container driven. But if you go back towards 1 and 2, So let's choose the 2 one because we want that laptop from NVIDIA with the tools installed because we want to save some time here. Otherwise, we'll have to install ourselves. So here, if you are here, what you can do is that it says that AI user managed notebooks will support. Okay. Now, what they want us to do is that they have made some changes in their system. And if so, this is what they're recommending. So what they want to do is that they are saying that they have made certain changes here. And the changes they have made is that now the framework that is installed, that is managed by Google themselves instead of we managing it. So that's a change they have made. And if you go to the managed notebooks, you will see here that now this is the one that if you want to migrate, you will now. But Workbench is is where you will have those notebooks where you will write code. Now, if you go back here, writing the code is where you will do data. Uh, data understanding. You can create visualizations. You can prepare the data if you want. You can do modeling. And then you can do evaluation as well. So you need other tools once the model is trained. Now, once you write the code, the output of this is basically uh, the a trained model. you know. So once you have prepared the data, you have understood, you have formulated the causal relationship between the features in the label, and the output of that is a trained model. That model file is the causal relationship that says that, okay, this is when it will rain, this is when it will not rain. So all those rules, they need to be stored in a database. And the database of where these models are stored, that is called a model registry. Now, this model registry is an important point in any machine learning infrastructure because model registry is the output of our dev process, the deliverable, the final outcome of our development team is a model that is stored in model registry. And in production, that model is taken from the model registry and there is an endpoint that is created around that. So model registry is in a way, you can think of that as the international border between two countries. One country is dev and the second country is ops or production. ML ops, if you think about in terms of machine learning, ML ops, first part is ML and the dev process, DevOps in the traditional software engineering, we call it ML ops in machine learning. So the output, the deliverable of the dev process is a model that is the trained model that we have trained after spending lots of time, lots of energy, lots of resources, and that is stored in a database that is called model registry. And that model registry, it shows up right here. On left hand side, you will see that there are model development, training, metadata, deploy. This is the model registry. So when you will train a model, it will appear here. In webinar, of course, I cannot train a model because it takes a while. But any model when you train, model training is a time-consuming step. But once you train the model, it will appear here. Now, important point is that you can also import a model. Now, that makes us curious. What is meant by this? It means that now this is an important point. I want you to listen here carefully what I'm saying because it will open up your horizon to new skies, new possibilities. So what I'm saying here is that now what I said was that in a way you can think of let me draw a diagram here. that when you are doing machine learning, there are two parts of the stories, two different environments. There's a dev environment, and then there is a prod and dev ops, as we used to call, make it thicker. We used to call them as DevOps. You must have heard this in one way or the other, right? In machine learning, what we have done is that we call it as MLOps. And what is this? What is this all about? This is all about this, as we know, this is development. And this is production. And if you look into this, development, your developing team is working on a model. It's developing and developing and developing. It may take weeks, it may take months. In some case, it may take a year. For models like ChatGPT, it may take a lot of time to get things done. But the output of this one, as I said, is model registry. It's right in the middle. I said that you can think of this as the international border between, is a lighter note, on these two countries. And the output of this one, it goes here. And the input, it goes here. And right now, we are developing both of them in Google Cloud. But as we saw here, you can import a model as well. What does that mean? It means that it opens the system for the possibility that you can train the model somewhere else. And just as long as you store the model registry in the standard format, as long as you store the model in the standard format file, you should be able to import that in this database of model files that is called model registry. It means that you can have AWS, you can have a Spark on your on-premise system or something else. So it means that you are using what what we have is we are using an external system, external to Google Cloud for developing the model, maybe your laptop. So this is Google Cloud. Let's bring to emphasize this, let's bring this from here. This is Google Cloud. And this is Google Cloud as well. Now, and this is Google Cloud as well. Model registry is in Google Cloud. But as long as you follow the standards, you should be able to import the model that is trained somewhere else. And you can flip it the other way around as well. AWS, for example, AWS has model registry as well. If you go to AWS, it has model registry as well. So you can develop the model in Google Cloud, store and import that in AWS, and it means that in production it can go in AWS. And why we will do that? There will be all sorts of reasons. Maybe this is to connect to a larger ecosystem. This may be basically to connect to the next phase. So again, reasons can be more than one, and you can think it through, but the possibility is there. Now, the deliverable of the dev process is a file that we import that in model registry, what is the deliverable of the production? Anyone who can answer this question for me? So the deliverable of production is an endpoint. There are two possible ways you can bring the model in production. If the model needs real-time access, it needs to be used in real time, like fraud detection at a bank. You swipe your credit card and someone needs to check that whether someone it's a fraudulent transaction or not. Or it's a police system who is using AI for enabling patrons, or all sorts of use cases. So for that, we will have endpoints. We will have an HTTP endpoint, and that endpoint is right here. If we go here, you will see left-hand side. So you will see here on left-hand side, you will when you will import a model here. This is where you will create an endpoint. So this is where what it will, once you complete this, it will create an endpoint for you. Now that endpoint can be used to make a prediction. If the model is pre-trained for you, if there's a pre-trained model, someone else has trained the model. So in that case, you do not need the details of which data is used to train the model, how they have done the data engineering, how they have prepared the data, anything else. All you need is basically those endpoints. I'll go in a minute to show you some of those models that are out there. But here, if you look into these, so the second way is that online predictions is what we call it as these endpoints. It will create endpoints that will show up here. So these are online predictions. So there are two types of predictions on left-hand side in CRISP-TM lifecycle. You can see here that online predictions and batch predictions. Online predictions are real-time predictions, and batch predictions are towards the end of the day or towards top of the hour. What we will do is that we will see that we do not need real-time access. We will just submit a spreadsheet, and the model will just label them, those 1000 files, 1000 rows, and will give us, it will be much cheaper, but it will not be in real time. Okay, now let's go back to our slides and see that what we are going to cover there. Let's take a quick 5-minute break, and then I'll start on the remaining topics after the break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off.
I have given you the introduction to AI and ML. We will look into that in detail. We'll also explore that what are the data to AI tools and techniques, the specific names of those techniques. And a topic that I am quite excited about teaching is about the Gen AI capabilities. There are lots of Gen AI capabilities. This is a area that is under development. And then we'll also make sure that we know we have the knowledge to choose the right tools for AI development. And finally, we will look into this life cycle end to end, how we can create these models. Now, objectives is it's a webinar. It gives you a pointer towards how you can go further, how you can learn, how you can understand the strengths of Google Cloud. Google is second to none when we talk about AI. So when we talk about AI, this is the strength. This is the primary business of Google. And that's why the tools and the frameworks that are coming out of it, they are second to none as well. And a machine learning model is useless unless you start using it for large scale practical applications. Otherwise, it's just an academic model. So we look into the practical examples and use cases where it should be used. And while we are doing it, we will keep an eye on the best practices. And now machine learning is one of those areas, one of those use cases where ethical consideration, making sure that we protect vulnerable communities, should not be an afterthought. It should be baked into the design and the architecture of the system. Now, when we talk about AI, artificial intelligence, I defined AI, and if you recall, we said that it's the simulation of human intelligence by machines to perform tasks like we identified 4 tasks. Anyone who can think about it? Yes, we said learning, reasoning, problem solving, and decision making. This is what makes us an intelligent species. And if we want to mimic that from the machines, that is not the actual intelligence. We are trying to simulate the human intelligence. So we call it as artificial intelligence. And now this is one of the ways where it can have a large scale impact on the way we approach a problem and the potential scale at which it can operate. It makes it a revolutionary technology. Now, Google, as I mentioned, that Google is one of the companies that is their primary business is about indexing the web, about understanding the sentiments, about pointing people in the right direction. So this is why the algorithms that are coming out of Google is the catalyst for the current AI wave that we are having. OpenAI has definitely developed ChatGPT, and Google has Gemini, and the other Facebook has, of course, developed Llama. But all of these large language models share the common academic research, and that research is coming out of Google. If you have looked into the paper, attention is all you need. That is essentially the basis of all of this research. So that makes Google at an advantage. Because Google has the organic native capability to attention is all you need. This is the paper. Now this paper is essentially the basis of the current revolution, generative AI revolution that we have. Now, if you look into this, that makes Google's leadership, it makes it an established leader. And combine that with the infrastructure that they have because of the scale of the problem they deal with, it creates so many advantages when you move to Google. And Google, it provides end-to-end model for development. And Google uh, has done lots of research in responsible AI. And the way it works is that they have what if tool that uh, tries to look into the likelihood of approving two people with one dimension that is different. And let me give you an example here. So let's talk about this responsible AI and what is the Google's approach. On top of everything else, Google, what it does is that it adds another layer. It also provides uh, with a black box approach to make sure that the models, they are not biased. And the way this is done is that let's assume that we want to see that whether there's a gender bias between the salary in an organization. So what we can do here is that what if tool, everything else remains the same. We change the gender and we see that what is the impact in the predicted salary of a person if the gender is swapped. What if the race is swapped? Is there any impact on the predicted salary if the race is swapped? What if there is something else that is there? So that essentially tells us that from the black, we don't care how the model is implemented. We don't care how the data is gathered. But on top of everything else, on top of all the white box solutions, we have this tool that anyone who is not even has anything to do with algorithms can test and make sure that the decision making coming out of it, it is not biased for any vulnerable community. We can have those tests there as well. Now, if you want to look into the key components of Google Cloud, so we talked about different ways. So there are essentially different levels, 4 different levels of sophistication you can use that. Let's talk about it. So when we talk about Google Cloud, so we have this CRISP-DM lifecycle, and there's a reason I showed you this. Let me copy it here and let's talk about. I said that there are 4 different approaches, 4 levels of sophistication from one extreme to another extreme. The first level of sophistication is in terms of effort, you take ownership of all the phases of CRISP-DM life cycle. So you are responsible for business understanding. You always are, but you are completely responsible for understanding the data, for preparing the data, choosing the algorithms, testing it comprehensively, and then deploying it. So you're doing everything by hand. This is the first way of doing it. Let me write one here. On the other extreme, what we do is that we do not take any ownership of what's there. It's like going to a pizza shop and say, I want pizza, without caring or about that how that order will be fulfilled, which ingredients will be used, how those ingredients will be fetched, what will be the temperature of the stove, how many people are available to prepare the pizza. You only need basically pizza and it should be good. This is the other extreme. So I first talk about 4 and 1, and then we talk about what's in the middle. Now here, this is number 4. And here what we want is that we want these pre-trained model. I don't want to be involved in. I don't even know which data is used. What we are doing here is that we are actually here. We just want to use this thing from actually, if you want to draw this circle here, it will make perfect sense. And look, because it's a black box, so let's complete the story. So this is all black box. We don't know what is inside it. We just want to use this model. We are given an endpoint and we want to use it. So the first approach is called, there are names for it. Google is providing us names. This is the custom model. And on the right hand side, what we have is this is pre-built model. What's the example of it? Is there any model that is available? Yes, of course. Let's look into one that are created by Google, one of the best ones in the business. Let's use it. In fact, you can use it as well. So what I'll do here is that let's go to Google. Let's write um, Google NLP model. Now this natural language AI, this is one of the best examples, and because this is such a powerful model, one of the best in its categories ever created by anyone across the globe. But it's a black box model. We have only the endpoint. We do not know that which algorithm was used to train this, which algorithm was used to process the data. We don't have any idea about it, right? So what we'll do here is that if you want to use it, we'll scroll down here. And what we say is that let's try to analyze something here. Let's write something here first. This is a live webinar on Google Cloud. Google Cloud is a powerful tool. Its strength lies in its power to process huge amount of data and use them for model training in a realistic time. But it will require some training. I'm teaching this course from the cold, frigid grounds of Ottawa, which is the capital of Canada. Now let's try to analyze it and see that I'll make it just a bit bigger so that it may be a bit small for you. Let's analyze it. It may ask for a human check. Yes, I'm a human. But all of a sudden, what it has done is that it has. Now, this is a black box model. I have not trained it. I am not responsive. I don't know which data was used to train it. I don't know how it was prepared. I don't know how whether it was done in a way that is ethical. I trust Google, but I don't know. It's a black box. Which algorithm? I don't know how they have selected the algorithm, but it works. It has done the end. So there, it has done 4 different analysis. You can see here. Entity, and this is part of Google Cloud, what I'm showing you. It has done the entity analysis. You can see these entities are there, these organizations, tools, and the sentiments coming out of it. What it says is that these are the sentiments that are coming out of it. They are positive or negative. Moderation, So especially in today's era of social media, where our language, it can do real harm, large scale harm, hate, insult, profanity, violence, it checks against everything. Then it tries to do topic modeling as well. So all of this is done. It's a pre-trained model done by Google, and we can use it. So these are two extremes that we have. One, there are two in the middle as well. I'll talk to this, but these are two extremes. On left-hand side, you have a custom model. On right-hand side, you have a pre-built model. What lies in the middle? Anyone who knows the answer to it? What is 2 and 3? If it's 1 and 4, there has to be 2 and 3, right? Let's think about it. So just before number 4, number 4 is that we don't have any control over data. We have a solution where we call it auto ML, something Google is very proud of. Google thinks they are pioneer of this whole technology. This is called auto ML. Auto ML means, let me write the number first so that you are aware. Number 3, and this is auto ML. Auto ML is that it's on your data, but it's a push button solution. On a lighter note, again, I just take it on a lighter note. Don't take it seriously. It's a conspiracy to replace data scientist with an algorithm. Now you get my point. So whatever is done by a data scientist, if algorithm can do that, it means that algorithm is doing data prep. Algorithm, no, it's not data scientist who is doing data understanding. Algorithm is doing it. It's not data scientist who is doing the second phase, that is data prep. Algorithm is doing it. It's not the data scientist who is doing modeling and selection of the algorithm, and it's the algorithm who is doing it. It's not the data scientist who is doing evaluation. It's the algorithm that is doing it. And again, it's the algorithm, not the data scientist, who is deploying this whole thing and creating the final endpoint. It's a push button solution that is called auto ML. And it means that, but what's the difference between this and pre-built model? For pre-built model, it is not your data. So it means that it's a generic solution, use it or don't use it. You have no control over it. This is on your data. Your data, your use case. Think about this, that whether it can replace a data scientist, should we start looking for plan B? If that's the case, so think about this, and if there's time, I will discuss it. That why it may not be possible. There is mathematical reasons, because I'll give you a hint here that I said that this whole area is about 3 things: mathematics, programming, and domain knowledge. If you are in immigration, you need to know your domain. If you are in healthcare, you need to know your domain. And domain knowledge is absolutely important. You need to fully understand how the manual process works before you give AI a try. This algorithm has no ML, auto ML does not have domain knowledge. It means that for the use cases where domain knowledge is not needed, classification of flowers, iris flower. If you're a doctor, if you're an engineer, if you're a government scientist, if you are in Mexico, if you are in Canada, if you are in Brazil, classification of the flower is irrespective of your domain. Domain knowledge is not needed. Auto ML will shine. Use cases now, let's turn it over. If it's the prognosis of a disease, a doctor knows that. If a doctor or a data scientist with a medical background trains a model, knows the sensitivities around that, and knows that when to use common sense, and that data scientist can bring the common sense and make a pedestrian model the top class model. AutoML cannot do that. Now, the mystery is the second box. We have 4 boxes, 3 are done, 1 is remaining. Now, what about the second one? Second one is about, it's a technique, it's a tool. If you have heard about this, BQ, BigQuery. Now, BigQuery is, first of all, BigQuery is a monster tool. It's a huge tool. In many ways, again, this is my perception, don't quote me on it, 50% of Google Cloud is just BigQuery. It's the favorite tool. All paths in Google Cloud lead towards such a powerful tool, so well done that people, I have taught these courses to Uber, Boeing, Walmart, you name it, HSBC, all of these companies, these huge names, Shopify, they are there in Google Cloud due to BigQuery. BigQuery is what the reason that they are in Google Cloud, and this BigQuery, it's a full power of the Google Cloud from the comfort of your browser and from the ease of SQL language. In this area, we can assume everyone knows some SQL language. Everyone has a browser. This is all you need to take full advantage of the cloud, and that tool that comes, the can do making that happen is BigQuery. Let's look into BigQuery. What is this tool that Mr. Imran is bragging so much about? So if you go here, if you go to, okay, we have done this, yeah, online. Okay, so if you go here and if you write BigQuery, BigQuery is right here. This is the complete power, almost the complete power of Google Cloud from such a user-friendly tool. And if you just want to use that, you go here, write a SQL query, and um, let me give you a demo here. So first of all, the whatever you are looking at is the query window, and what you can do here is that you can just write the code there, and you should be able to use it. Now, if if you want to use it, there are data sets that are called public data sets. So if in public data sets, when you want to use public data set, it means that you do not need anything else for that to happen. So let's look into this. So let's say here, let's use it here. So here what I'm doing is that I'm using this is a public data set. And what I want to do is that I am looking for the names that are there. Now you see that what I said was that what are the most common names? These are most common names that are there, total babies that were born. Now, the thing is that this has the power, it seems very simple, but it can deal with huge amount of data, unbelievable amount of data. And the price that you pay is per query at a very low cost. You can save the results. Now, this tool has been extended to BQML. Let me give you an example. So BQML is it lies in the middle. So what it means is that when I draw this diagram, the red box that is here, this is at number 2, and this is BQML. BQML is it takes ownership of BQML. It is semi-managed. Now let's look into the, so what it does is that it exposes 3 functions: create model, evaluate, and predict. And this is all that is needed for this thing to happen. So let's look into this, that how we are going to use it. Let's see that how we can train a fully functional model. Let me do a live demo on it. So now let's look into the what we will do here is that here. Let me replace this. Oh. First thing is that let's explore the data. Let's quickly look into this. What we are saying is that the name Mary, and if we run it, it shows you that name as in which state this name was in the 1910 is the data that we are using. So this name Mary, which state has this name how many times? There are 4 columns. Name is 1. We are not predicting anything. We are trying to understand, trying to see that what sort of data is this. Now what we will be doing is that we will create our training table. And for that, what we'll be doing is that here, the second thing that we'll be doing, let's get rid of it. This is so simple to train the model. Now we are creating a table that is essentially training the model. So if it runs, okay, project ID is I need to write my project ID. On in US, okay. Let's okay, let me give it a try. It should upload to the package, create dataset. This dataset is Okay, let me explain. Okay, so let me explain this through the code. I think we are getting an error to the region. Okay, so first thing what we will be doing is, let me show the results because I have the results here, that how it will look like. So first thing is that we'll train the model. This is step one. So what we are doing here is that we are training the model. Once the model so first what we'll be doing is that we will creating the table. Here what we are doing is that we are creating this table, and once the name, so what we are doing here is that the name is Mary and the gender is female, and based on that what we are doing here is that this is the table that we have. Year is the first column, and the sum, this is the second column. So it will create a table like this as we ran before. It will create a table. What it will do here is that it will be like this. The year will be there, year and number. This is what it will do. This is, and then what we will be doing is that we will be, uh, what we will be doing is that we'll be creating a BQML model. This is the training data set. Now this data set lies where? This data set lies here in the CRISP-TM life cycle. If you think about this lies where? In the middle, right here. Here. This is the table. If you think about this, in this context, there's two very simple table. Year and number of babies, that lies in the middle. What we want to do is that we want to understand, we want to train the model that can establish the causal relationship between year and the number of babies. And then we will try to predict. First, we will establish this, and then we'll give it a year, and we'll see that whether it can establish this or not. Now, first thing what we do is that this is step one. We just prepared the data. Now, what we are doing is that we are creating the model. So we used a particular year. We use a particular year as the maximum one, 2010. If the years before that, all of them will be there. And what we are doing is that we are trying to establish causal relationship between years and number of babies. And this relationship is nugget. This will be, once we have trained this, we will import that in model registry. And from there, we should be able to predict. Now, this is the dev in BQML. This whole thing is part of the dev. So this one is data prep. This is dev. We are training the model, and once the model is trained, we will put that in the model registry. And once it's there, we will evaluate. And once we have evaluated, then we will make predictions. So we will select 2 years. And what want to do is that we want this model. This model is this is we are using it. This is the production. This is the prod. This is the production. And in this one, if you look at the model name, this is supposed to be the same. You see the model name. This is the output of this one. This goes to the model registry. Supposed to go to the model registry, this one. This is the output here. So once you have used this, one, BQML. So this is now we are using it for predictions here. What it will do is that it will predict the what's in the production. It will create the endpoints, and here we are trying to we want to predict If here is this one, if feature is this, and this is this, what are the predicted number of babies? So this is what it will do. Now now this sits in between. It is, you don't have to do everything by hand. As you can see that in Seek, it can do some data prep for you. It can do some heavy lifting for you. You don't have to write complete code. There's SQL statements that will uh, that you can think about it. Okay. Now let's look at. Now this is we said that BQML. We use BQML to um, for AutoML. Now I think it makes sense. We use BQML here. Now I talked about the responsible AI. So these are AI built by Google. This is based on principles: safe, responsible, and the one that is there, responsible for social benefits and fairness, accountability, and high standards. Now, if you want to, now, if you want to look into the different options, I talked about the pre-trained APIs. I talked about BQML. I already talked about in detail AutoML and custom training. And I also talked about different workflows. And this whole thing I've explained that in detail. If there are any questions, please let me know. Otherwise, any questions so far? Okay, I'll monitor the chat. If there are any questions, please let me know. So let's look into the best practices and challenges. Now, the challenges are about how we can do this heavy lifting, how we can provide the model explainability, how we can monitor the drift, and how we can automate these whole things. So heavy lifting is done by Vertex AI pipelines. On left-hand side, you will in CRISP-TM lifecycle, you will see that there are different tools. There are tools for monitoring it as well. There are tools for doing capacity planning. All these are there. And one, let's go to the Vertex AI and see it from there. First thing that you will see here is in Vertex AI, there are machine learning pipelines that you can create. If you go here, Model Garden is there. There is data sets are there. Online tools are here. So pipelines are right here. So pipelines can do heavy lifting. Data prep, this is a heavy weight process, and we want to make sure that we have the power to do that. Now, when you talk about data to AI workflow, there are different stages in the workflow. And we talk about data ingestion, where we need to think it through that where the data will reside. And if one way of looking at the data is that it needs to be closer to where it will be processed. If it will be processed in BQML, then it should be residing in a table within BQ. If it's in a notebook, then S3 is a good option. So we need to think about this. And now BQML, I talked about this, that there are different components of BQML. It's a tool for building BQML using simple SQL queries. Simple ingestion, it supports and not all algorithms, but many algorithms, and it can create predictive analytics for sales data, for example. Now, Vertex AI, there is, you can have this. On the lighter note, don't take it seriously. I talked about the conspiracy to replace data scientist with algorithm. So whatever data scientist is doing on your data. So that is called AutoML. So this AutoML is here. There's a feature store as well. Feature store is that what we can do is that in Vertex AI, we can store each of the features independently. Feature is the dimensionality of our problem space, and if we want to store those features independent of each other, that is feature store. AI pipelines, Vertex AI pipelines, I just showed you here that these are the pipelines that you will create, and you will be creating that from a template. So the common processing jobs, you will find them to be shown here. Okay, now if AutoML, I talked about that in detail, so I will. Okay, now let's look into what is Gen AI and how we can use that. Now, Gen AI is making lots of hype these days. ChatGPT, BERT, Copilot. So uh, Google Cloud has a comprehensive solution, and the way you will do that is that there's a tool that is um, uh, yeah. So when we talk about Gen AI, we are always thinking about the risk of hallucination. There should not be. We are making sure that there is no bias. The best practice is that we want to make sure we have all the security that is enabled, and we have all the safety like the guardrails there on. We want to make sure that when we use that for critical decision making, we are managing the risk as well. So, and we regularly monitor and take at the decisions, and we are aware of the strengths and weaknesses of Gen AI. Let's look into what the tool they have in Google. So in Google, if you go to Vertex AI, again our single window operation, there is a comparatively new tool that you will see here. First of all, on the top you will see Model Garden. So if anyone has visited the site Hugging Face, Hugging Face is by far the most popular open source site that we have for large language models or the assets that are related to large language model. And what you can do here is that the models that are pre-trained, you go here, and all models you can find it here. You are looking for Llama, or you're looking for other models, you are looking for pre-trained solutions. All of them, you should be able to find them here. The Hugging Face equivalent of Google is the Model Garden. Here you can see Llama 3.7 instruct model. So the same one, if you go to Model Garden, you will find Llama here. The difference is that it provides you a complete hosted solution. You can host the model because you need a place where you will run this, right? So this is what you will be doing. So it means that Llama 3, for example, here you can run it. It provides a living environment. It's not the algorithm, but where you will, the infrastructure where you will run it, So all the models there, the Model Garden is there. So this is the Hugging Face equivalent here. On left hand side, you will see different categories of the models that are there. Now, this is again the pre-built. It's the equivalent of, now this Model Garden in Gen AI parlance, in Gen AI world, this is the equivalent of number 4, extreme right hand side. These are pre-built solutions. You have no visibility over the training process, how they were trained. Now, what is the dev environment in Gen AI? Let's talk about this now. So Model Garden is the number 4 on right hand side. These are the endpoints that you can use, pre-built solutions, or you can download the algorithms. In any case, this is the pre-built large language model. You have no control over the solution on it. But if you want to use it as part of the solution, on left hand side, you will see that there is Vertex AI Studio. Now, Vertex AI Studio, you can use that with Gemini. You can translate text, you can generate images, you can convert or synthesize text there as well. And for that, let's open the chat here. On right hand side, so first of all, you can write something here. For example, I am teaching a course on the strengths of Google Cloud in the space of machine learning. Create an outline that I can teach within a couple of hours. Once we have created that outline, populate that with contents. Now let's run it. So this is what it is proposing us. Now on right hand side, you will see that there are different ways that you can control this generation. First is the temperature. Temperature means that what you are doing is that you are controlling the randomness, the creativity, but it also increases the hallucination. So now let's look into this. What it says is that yeah, this is what it has proposed. End-to-end solution. So I like it the way it has approached this whole problem. And it has also given the time. You see that how good it is here. And right hand side, you parameterize this. It is a brand new model that is just it has made available. It's experimental, and I have selected that. And it is very fast as well. You know. Now here the temperature controls the hallucination. So if you decrease the temperature, it makes things more deterministic, but boring as well. But over and over again, it will repeat. On right hand side, it will make things more creative, but less deterministic as well. It depends on your use case. If it's the interaction between Canadian federal government as a Canadian citizen, you don't want, and that person is inquiring about a complaint. So that person needs information. That person doesn't need poetry, or we don't have to talk in terms of superlative terms. So we just need plain language. In that case, temperature should be at the lower end. We control the temperatures. The other parameters there, for example, you can see here, all those parameters are here. And there are other tools here. For example, you will see here that there is one for vision. Here, what you can do is that you can use it to control the vision, how you're going to generate the images. So if you can say here that I can um, I'm teaching a course on generative AI running on Google Cloud. Create an image that can help people understand this process. So what it is talking about, yeah. So you can, okay, so you will be able to, okay, so it will create those images, right? So you get the idea that then you can go back and see that how you can. So this is the primary tool that we have in Google Cloud for in this problem space where we are using it. Now, let's look into how we can choose the right option for AI development. Should we be using, if we go back here, should we be using custom model, using BQML, AutoML, or should we will be using pre-built solutions, or a combination of all of them? Let's look into this now. Let me stop here. Any questions so far? Everything good? Okay. I'll monitor the chat. If there are any questions, please let me know. So now let's look into that how we are going to look into the solutions. So we have pre-trained APIs, auto ML, custom models. Now pre-trained APIs, I talked about this, that they are ready-made solutions for built by Google for common generic tasks. And the examples are Vision API for image creation, Natural API, and advantage is that there are no expertise required for ML, so you just use that solution. The Auto ML is a low code solution. I talked about this. It's a pre-built solution, push button solution to train the model. Now it depends on the expertise. It also depends that how much control you need over the training process. Do you need to bring your domain knowledge into the model training? Then do not use AutoML. Do not use pre-trained solutions. Use custom solutions because you need to create those additional flags. You need to create those additional artifacts that can guide the model uh, towards the insight that you brought with your full understanding of the domain. That algorithms are incapable to do that. This is an important thing that is there. Now, it is also about the model complexity and the goals that you have. It depends on the team expertise, their exposure to machine learning. So if they don't have exposure to machine learning, then AutoML will at least give you a baseline expectation that this is the baseline expectation and take it from there. And it also depends on the timeline and the budget that is there. Now, if you want to build models with Vertex AI, the flow is that it follows the CRISP PM lifecycle. You will prepare the data, you will do feature engineering, you will do model training, deploy. And the benefit is that in Vertex AI, you are in a single tool. You can manage the complete life cycle of machine learning while within this single tool. On left hand side, you will see everything that you have, even now the prompt management, prompt gallery, whatever new things are coming, they just keep on adding within the single window tool, single window operation for AI, and that is Vertex AI. Now, if I talked about this as well. The best practice is that what you do is that uh, you do not over design, and you keep data closer to where you are going to train the model, and you monitor the model. And so in here you can define ways how you're going to monitor the model. You go down here, you will find that there are monitoring tools that you have, and these tools will uh, you will define thresholds for the accuracy. As the accuracy will drop, these models can trigger the events that you can catch and you can rectify after looking at the root cause of that model. Now, there are different use cases for this one. We are looking for large scale machine learning. Can be in for product recommendation like Netflix or Amazon, or for dating websites. These are all, or for for jobs and job. These are all use cases for recommendations. Can be healthcare. It can develop a prognosis for diseases, or it can also, if someone is discharged from emergency, it will try to quantify that what is the risk associated with that, or fraud detection models. Now, this is the summary. What we have is that the summary is that Google Cloud is a powerful tool. And in order to use that tool, 3-4 years ago, there was no single window. Vertex AI is Google's effort to consolidate all the tools that are there in Google Cloud related to ML. So it creates an end-to-end solution, and GenAI is now part of Vertex AI. And you can build the model. It's all about the CRISP PM lifecycle, from a question to a solution. The whole life cycle, going through the data prep, data understanding, model training, evaluation, and that is managed through Vertex AI, both dev and production. Whatever is needed, that is there. And this is part of Google Cloud. And this brings us towards the end of this webinar. Any questions?
Thank you, Imran. That was very informative.
Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the three leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So we, Netcom Learning, is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Now, next up, we are offering Google Cloud Fundamentals course, which is usually priced at $575, but we are offering this absolutely free of cost. So this is the full one-day course in which you and your teams will learn how to use Google Cloud services and tools effectively and gain a solid understanding of the core components of Google Cloud platforms. You will also get hands-on practice through practical labs, allowing you to apply your new skills right away. So this is a full day course, unlike our masterclasses and webinars. So we have limited seats available for this, and you can request enrollment by clicking here on this button. So submit your registrations to us as soon as possible, and our team will get back to you with the confirmations. Uh, Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla. And now we're going to go ahead and jump right into our question and answer session.
What are the primary advantages of using Google Cloud for AI ML compared to other platforms like AWS or Azure?
Okay, so Google, if you look into Google Cloud, because Google is a company that it is built on AI. So that's why you will see that this Vertex AI, this is the sort of in the center of Google Cloud. So it's not an afterthought. This is very simple to use as compared to SageMaker in AWS. There is no concept of a domain. It's streamlined within the larger ecosystem of Google, and whatever Google provides, this is the strength of Google. So for example, if you look into the algorithms that are provided in Model Garden and you compare that in Bedrock is the equivalent of Model Garden in AWS, you will see that it has a fraction, it has about 30% of the algorithms that are available. If you look into the assets that are there, assets are on your left hand side in Vertex AI. What you can do in Vertex AI, SageMaker, that is equivalent of Vertex AI, it has a subset of that. The reason for that is that AWS is great for data engineering, but when you talk about AL and ML, the variety of options that you have, the templates, pre-built templates that you have, pre-built solutions that you have, they are second to none. And the reason being that AI is the primary business of Google. That is not the primary business of AWS.
Can you explain the key differences between AutoML, Vertex AI, and BigQuery ML, and when each tool is most appropriate?
So the difference is that if you look into AutoML, in AutoML, what you do is it's push button. You cannot select the algorithm. You cannot select the data prep technique. All you do is that you provide the data, it will provide a solution. So in BQML, it can choose it if you want. You can use the facilities of BQML to prepare the data, but you have complete control over which algorithm you will use. You have complete control over how you can amplify the signal and reduce the noise. So that's why we said that in terms of control, we are on the left hand side, you have the maximum control, BQML 70%, AutoML 30%, and pre-build was 0%. AutoML 30% because data is yours.
How does Google Cloud's generative AI studio compare to open source alternatives like Stable Diffusion or GPT models?
Okay, so the difference is that because it's part of the larger ecosystem, if you go here, so this is what we were talking about. So now, because it's this AI Studio, this is part of ecosystem. It means that the models are pre-built. You don't need to deploy the models, number one. Number two is that because it can talk to the larger ecosystem. So it's not something, this is not a solution in isolation. It is connected to the larger cloud because in order to complete an end-to-end solution, Gen AI is part of the puzzle. It's not the solution. So that brings two things here. So it's a hosted solution. The second thing is that because being part of Google Cloud, it's part of a larger ecosystem.
Once again, I want to remind you that as you leave the session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.